Okay. Chapter 3, we are now in the power, work power and also efficiency. So just to recap, what is definition of work, or we put capital U. Work happen when your force and displacement go in the same direction. So when you take force ds, okay, du equal to f ds, you'll get work. So if the two arrow is same direction, then you get positive work. If it's opposite, then you get negative work. Okay, so this is a general equation. So if your s is defined one value, then you can straight away write u equal to f dot s. If your s or your force is not constant, there's an equation, then you need to do integration, right? Okay, or you can write u equal to force dot s. So all these are vector form. Then power equal to work du dt is a time differential of your work. Then efficiency equal to your output divided by your input. So it can be energy, it can be power, yeah. So these are the ratio, three equation for chapter 3. So chapter 3 basically deal with force, velocity, and displacement. And also, if you want, you have time. But time is not the parameter. Time is usually the time differential of your equation, right? Okay. So back to this question. So you look at the question, you see a pulley, and then you see datum. So you recall the step for pulley first, right? You see the question without reading the detail of the question. So what you do is you see pulley, then you, let me see. Okay, so when you see the pulley, then first step is to calculate the total length. Okay, so just be careful on the datum. You calculate lah. So here you have SC plus SC plus SP. Okay, so you have a equation there. Then you can find the speed for C and P. Okay, C and P. So then the next step is dt of the previous equation. You get 0 equal to V something plus V something. Then you rearrange, you get the opposite vector of the 2V. Next step, you time differential again, you get acceleration of the two body. Okay. So this is the first step lah. Every time you see pulley. And then usually if the question, you read the question, example 7, if you see the question, you see motor. The word motor will give you power already. Okay. Motor of the hoist lift 35 kilogram of crane C. So the acceleration of the point P is 1.2 meter per second. So if you're given acceleration with a constant value, then you can use the 3 Newton equation. Okay, you see mass, you see acceleration, straight away F equal to ma. And then you recall the 3 Newton motion equation. That is just to ready the steps at the side of your working step. Okay. Determine the power must be supplied to the motor at the instant P has a velocity of something. In this case, you're given one value. We're given a V, and power also equal to force multiply velocity. Or power equal to work divided time differential of your work. So there are two lah. So ignore the mass of the pulley cable and take your efficiency is 85%. 0.85 is 85%. So efficiency is input and output. Okay. So when you look at this kind of question, you write the general equation first. Anything that related to the parameter, you write on your answer sheet. So you write the definition of efficiency. Okay. In this case, you need to find the power. So meaning that you need to take power output divided by power input. Then from there, you reverse back to the parameter that is missing. That is how you solve the question. Yeah. I hope you can see how you solve. When you read the question, you see the scenario, what you need to do first. That's more important. Not memorizing the formula. Okay. Okay. In dynamics, usually you need to draw diagram. Okay, so for C, you have a pulley, so you have a two tension cable and one tension cable going down. So you draw the free body diagram for the package with the C. So free body diagram always start with W at the center of the object. W equal to mg, and then there is then once you solve for W, then second step is to put in the external force. Right? Then you solve for internal force, friction, drag, and all this. Right? So for the parcel C or the weight C, you have two tension, two T pulling the thing. Okay. You can put T, but later you need to use half T. So we just simplify the equation. And our datum is going down, positive, based on the datum. Okay. Datum. Okay. So you imagine if the pulley, if the motor rotate to the right, if the motor rotate to the right, the thing will go up. If the motor rotate to the left, the thing will go down. But anyway, if it's a pulley question and you're given datum, you need to follow the datum direction. There's an arrow given here. Just be careful on the positive, negative direction. And then you put in, after your free body diagram, you put in a kinematic diagram on the same diagram. In this case, it's A. Of course, it's a MA. It's a MA. But that is just to tell the direction of acceleration. Right? Because we are not using the equation of F equal to MA later. Okay, so for free body diagram, the red arrow is actually to show the acceleration going down, positive. Okay. So you start with the y direction, F equal to MA. Then you look at your free body diagram, all the force is on the left, and then the kinematic motion is on the right of the equation. Put in there, so W positive go down, tension go up, equal to MAC. So you solve object by object. So this is the first equation. You put in the known value, then it become equation 1. You know the W equal to mg, mass is given, gravity you know. Then you get T equal to something A. Okay. Then the next question is to link the C with the motor. So you link C to motor using the pulley equation. All right. So from the diagram, you know that if you pull P one time, let's say you pull 1 meter per second, C will go up 0.5 meter per second. It will slow down half because two cable. Yeah. So you start with the pulley equation, total length equal to something plus something. So this one you have 2 SC plus the length of the datum of length of the cable to motor SP. Okay. So in this case, you can find velocity, and then you find acceleration. Yeah, so this one I assume you already know already. So I just skip the second steps. I skip the second step where I skip the velocity step. But if this one in your assessment test or final exam, you need to derive the equation for velocity and acceleration. So AC equal to minus half AP, meaning most of them is going different direction. Minus here, negative here, it means different direction. Yeah. So when you have the relationship between AP and AC, between the two objects, you substitute, you know AP is given. AP is 1.2, is given in the question. So you just substitute and you're able to find the acceleration of C. Once you're able to find acceleration of C, C linked to the pulley, linked to the object, which is AY here in the first equation. Substitute there, you find your tension. Once you find your tension, you need to calculate power, right? Power equal to force multiply velocity. Substitute and get answer already. Okay, so here you get the tension value. When you substitute into equation 1, tension equal to 182.2 Newton. Okay, all right. Now, if you see these slides, every time you draw free body diagram and kinematic diagram, usually you can solve tension. If it's involved with pulley, then we will solve tension. If no pulley is on the ground, normally you solve normal force. Normally, yeah. Then normal force, then you solve friction force. Usually like that. Okay, so you know power equal to force multiply velocity, or power equal to work divide by time, or time differential of your work. So in this case, the question do not ask you to find work, so don't go and do work procedure. The question asks you power, then you do power question, then find anything that in the question. In this case, velocity is given, so the hints is you need to use the P equal to FV. Okay. So your F actually is a tension cable, because if you look at the diagram, so the tension cable linked to the motor, the SC cable here, you link to the motor. You already find the T already. So T is the same magnitude, not direction, same magnitude as the tension cable relate to the motor. So T, you substitute 182.2. Velocity of the motor, you know, is 0.6. So you manage to get the power. So this is how you ideally calculate the motor that you need for a certain system, for hoist system or in the crane system. So this is how you find. Okay, when you design crane car or crane object that lift a certain object, as long as you know the weight of the object that you want to carry, you want to find what is the speed of lifting, then you can find power. So the answer is 109 Newton meter per second, or joule. Oh, sorry, not joule, watt. Okay. If you forget, you just look back at the parameter. P is Newton, velocity is meter per second. You combine the two, you get Newton meter per second. Okay, so this is 109.3 is the power needed to lift the object. But you know that there's nothing perfect on this earth, especially man-made object. So there is an efficiency there, 85%. So you need more power. You need more than 109 to lift the object at all this speed and acceleration. So what you do, you call out efficiency equal to energy output divided by input. On the left hand side, you know, it's given by the thing. All right. So so your input is known. So you need to find your input. Okay, you substitute value. .93 watt divided by 0.85. So 85% is on the left. So you know that if you have 85, you need more input than the output. So the value, the answer for question 7, example 7 is 129 watt. Yeah. Mazin tolong teks yang tak datang. Okay, we have done with the example 7. Okay, these are the last section for chapter 3, which will be asked in your final exam. So next step is conservation of force and potential energy. So you know that forces, you know, when you see the conservation, the word conservation means there's no change of energy. It can only move from one form to another form, right? So potential energy, you know, is mgh. Kinetic energy is half mv squared. So these two will be interchanged when you do conservation of force. Yeah. So conservation of force means force can convert into energy. Energy can convert into force. So basically, we're playing with F equal to ma. Things that move, things that have velocity, have acceleration, you can convert into velocity. So when you have velocity, you multiply with force, you get power. Power is energy. Right? So and so on. So potential energy, we have a few things. We start with spring first, and then mass. Mass is the one that you learn in your physics, mgh, with potential, but spring also mgh, but I will show you how. So conservation of force, there's a definition. If the work of the force is perpendicular to the path, means we're not dealing with the displacement. It only depends on the force initial and final position. Then we have the conservation of force. It means if the question mentioned force is independent of the path, then the question fall under this 3.5, conservation force and potential energy. Okay. Now, for example, weight done by work done by weight or W is depend only vertical displacement of the. We know that weight is under acceleration, gravity force, right? Gravity force always go down. So W multiplied by the displacement distance, then you do work, right? the force developed by the spring, the work done by the spring force depend on it on the spring elongation or compression. So you know that when you pull the spring also do work, but it's depend on the either you pull or you press it. Okay, like what you see there. Huh? Okay. So these are the example. Is when you can use conservation, when you cannot do conservation. So I give you one example that conservation cannot be used. Conservation cannot be used when you tilt an angle and friction involved. So consider friction on the sliding object. The force is multiplied by distance traveled by the friction force. Then conservation force cannot be used. Meaning the more path or more path traveled by the friction, the bigger the work. So the work is cannot be conserved. Okay, so when you see the question that give you friction coefficient, you need to be careful already. Don't confuse, don't use conservation of force and energy equation. Okay, so we will come to more example. So friction force is not conservative. Okay, now we look into the first example of potential energy, which is done by the weight. Okay, so let's say we have an object moving from the top to bottom. However, in this question, the datum is at the middle of the question of the object, or position of the object, datum at the center. So for potential energy, just remark, potential energy, datum is important. If you see the question with datum, your potential energy, you need to be careful already. If your object is above datum, your potential energy is positive because you see this one as Cartesian plane. You go up positive, go down negative. So if your datum is positive, go up. Above the datum, then your work or your potential energy is W, force multiplied by the positive displacement. Force in this case is W lah, but basically it's just force multiplied by the displacement. Fs. Work is Fs. Work is energy. So W multiply the H in this case is plus Y. If the datum is at the center and your object go down, then you have negative energy or negative work. Important. If you see it give you datum, basically it will ask you potential energy. And if the object is on the datum, no energy, no potential energy. If the object is on the datum, W multiply distance is 0. So potential energy V, in this case, it's not velocity. It's this one is a V. In this case, it's a potential energy. It means potential energy, not velocity. Okay, the rest I will just go very fast. Okay, first is about potential energy linked to the position of datum, that link to weight. Weight, datum, you need to see if it's above datum, you get positive energy, positive potential energy. If it's below the datum, then you get negative potential energy. Now, application of this one, if you have a sport diving, you dive from swimming pool, there's a certain height, you jump. Above the water, you jump very high, so potential energy positive before you jump. When you go into the water, sea level or water level, you get negative energy. negative potential energy. Something like this. So this is a potential energy referring to datum. Referring to the datum. Next, we look at the spring. Also, it starts with the original position. So you have three positions: spring, before stretch, stretch, and compress. So the first one, without stretching, no energy because no force. All right. Energy equal to force multiplied by the distance traveled. So Fs or work. So potential energy for the spring, if you pull towards the right, you calculate the force of the spring. Force of the spring is what? How to calculate force of the spring? F equal to spring multiply coefficient of spring multiplied by the distance. Right? And then you do work. When you do work, recall the mathematic model of the work. Okay, force spring equal to spring, equal to K spring multiplied by the distance. What is work done by the spring? Work is what? Force multiplied distance. But spring we don't know, so we put in du and ds. So when you have this one, you integrate the spring energy or work. So force, you have ks dot s here and ds. So here you pull out the constant ks and you integrate s ds. So here you get this one. This one you get half s squared plus c, because this one no limit. If you integrate something, you have a constant value, but usually you have a limit there. Okay, so that's why you will see the formula on the screen here. The work done by the spring is half ks squared by what I write on the whiteboard here. Okay. So if you see the spring compressed from the original position minus s, if you substitute into half ks squared, you square the s, negative s squared, you still get positive. So spring energy always positive. Yeah, spring energy always positive. Yeah, so there are two things here. One is work or gravitational effect, W. W depending on datum, above datum positive, below datum negative. However, if you see spring in the question, your answer will, your energy for the spring will always positive. And the equation you straight away can use half ks squared to calculate the energy for the potential energy for the spring. Okay, potential energy for weight, you can use mgh. You can recall from your physics mgh, or usually because in dynamic we use W for mg. Right? And the y, if you're not comfortable, you can use h, positive h or negative h. Right? Okay, we have two scenarios. So throughout this chapter 3, you only will see two scenarios only, either W or spring. So since you know that this chapter we only discuss about two, so when the question asks you to use conservation of force and potential energy, your total potential energy is a combination of gravity or weight and the elastic energy of the spring. Or you can write V gravity or VW plus V spring. Only two. So if the question do not have spring, then sure they will have mass. Yeah. So these are the general equation. So in this case, if you move an object from away from the datum, you will create potential energy. And only we deal with two. One is W, one is spring. Spring force, spring energy. Okay, spring energy equal to half Ks squared. Potential energy for weight is mgh or Wy or Wh or Ws, depend on your preference, as long as you label clearly in your answer. Okay. So the work we use capital U from position 1 to position 2. Position 1 to position 2 is a total work that you done for in position 1 and position 2. It depends on the datum and how the spring is stretched. Yeah. Okay, so here we combine the two scenarios. We combine spring and weight in the same devices. So you have spring and the green ball there. The green ball have mass. Mass will create weight going down. And you're given a datum at the middle of the spring. So we start with concept of conservation of force and potential energy. So we start with total potential energy or total potential energy. You cannot use total energy. Total energy, you will involve kinetic already. Later chapter, we'll consider all the energy. In this case, we focus on this section, we focus on potential energy. So V equal to potential energy of the weight plus potential energy of the spring. So you put in the equation. Okay, the weight potential energy is minus Y. Y minus Ws. Why? It's below datum. It's below the datum line. That's why you get negative Ws. And the spring, no matter where is the datum, is always give you positive value, half Ks squared. So if particle move from S1 to a lower position of S2, means it's go down. The work done by the weight and the force spring, you need to put into this equation is the work before minus work after. So you put in the equation U12 equal to V1 minus V2. So you just change the substitution, the sub notation for the work and for the work. This one is it? This one because below the term. But the work, if you do comparison of 1 and 2, you take 1 minus 2. Minus. Sorry. Plus. Yeah. So different is minus. But you can put yeah, minus. You put in bracket minus. It's not plus. It's a minus. Yeah. So you put inside the equation and you rearrange and you factor them out. You put weight effect and you put in spring effect. So weight effect, the difference only the W will not change. The force of or the mass doesn't change. So the weight always same. Only the position is different. So there's a change of position multiplied by the W. Basically, it's your mgh, and the spring is 2 square minus s1 square. So this is a general equation. So this one you can derive. This one you can derive in the question, in your answer. But what is important is you know how to find the differences or the work done by the weight and the spring. If you have two objects combined together, spring and mass, then you use this formula, then you calculate back. Okay, the rest is this is for your info. If your object move in the three-dimensional, then still same. I mean, don't confuse by the mathematical order here. If you have 3D means every direction have one work. X, you have work in the X, you have work in the Y, work in the Z. Okay, I won't ask you this one in test. But the concept is just that if the object move in one direction, there's a work there. And we only focus on the XYZ direction. Either go up, go down, go left or right. Yeah. Now, if the object move in the angle, let's say you have X and Y and they move in the angle, you only need to split the angle into X and Y if it's 2D question. Okay, if 3D, then you do vector lah, IJK lah. You split the resultant force into XYZ component. But we won't go deep into that, all right? Okay, this one you just read through. Just read through. So read through, I won't ask you. It's just mathematic order. What is important is this one. You split your force into IJK. And if you go into mathematics, means you use metric lah. You use metric, force multiply X matrix and so on. The rest you read. The rest you read. And if you go into year 3 module, especially thermodynamics, aerodynamics, then you will see this symbol. You'll see an inverted triangular. It just means that if you see inverted, means there's a change of X, Y, and Z. This inverted triangle means this bracket things. It's a mathematics. All right. This is a partial differential. When you see this one, you need to use limit 0 to 0, something like X equal to 0, then you change from this one to D something. But I won't ask you that lah. That is more on mathematics. Okay. And this one we call vector operator. For dynamic, I don't ask you three-dimensional question. Unless the question is very super simple, then I'll ask you 3D. Okay. Okay, next. When the particle act upon a system, means we have conservative force and non-conservative force. So the principle of work and energy, the word here is principle of work and energy and not principle of work and potential energy. If you see the question force you to apply principle of work and energy, you need to consider kinetic energy and potential energy. If the question force you apply principle of work and energy, you need to, the word energy here, you need to consider kinetic energy and potential energy in your equation. So you know that you have two types of energy, kinetic and potential. So if you write the previous one, principle of work means you write work equal to work done before minus after. So this is the structure of the equation. Energy before T1 plus V1. V is energy before plus the work done. Work is not conservative. Why? Why work is not conservative? One is friction, and then what? What is the formula for work? Work is you look at what vector? Force and displacement vector, right? F multiply S, right? And these two vectors must always parallel. We not care about direction. If the same direction positive, different direction, a different arrowhead, negative. But force must link with the displacement. So when your force link with the displacement, then it's not conservative. Yeah. So if only conservative of work is done, means if the question asks you to calculate this one, you get one answer. The section C or section D of the question is ask you to consider conservation of force and energy in your answer. Only then you rearrange the equation and you cancel out the non-conservative part. You will get T1 plus V1 equal to T2 V2. Basically, your energy doesn't change. Means before equal to after. Before equal to after. And you only look at the conservation of force or energy. Means you only have kinetic and potential. Meaning only consider kinetic before plus potential before equal to kinetic after plus potential after. Basically, only look at gravitational force, mgh, and half mv square. These two formula before equal to after. Okay, so this formula is known as conservation of energy, means you only look at two type of energy, not two type lah. Kinetic half mv square, potential half mv square. If we have spring, then you need to use spring energy equation. Half kx square. So only these three lah: spring, weight, and your datum h, w effect, h effect. So we continue to develop. Look at the question. If you have ball bouncing from the top to bottom, and your datum is on the ground, this is just a derivation of mathematics. You know that on the ground, if you drop a ball from the top to bottom, at the top, you know that potential is maximum. Before you drop, no velocity. So kinetic 0, half mv square, no v. Then at the middle is half lah. Then at the bottom is potential 0 because datum is on the ground. mgh h0, but kinetic maximum because maximum velocity. And then half is at the middle of a h is half lah. Okay, so if you this is just a derivation. Go and read. You go read on my slides. Basically, it's just a derivation of equation. This is chapter 1, Newton motion equation application. If you know the velocity before, after, you know the before, you have a constant acceleration, in this case, free fall. Free fall, you have constant acceleration, which is 9.81. And the change of your s, in this case, is y, right? And you rearrange and you substitute this one is half, if the h is half, then you can derive the equation for the velocity. But this is just the example. Just example how you use the equation. So v square equal to 0, because you start with 0, you let go from 0, to g, h is half, then you cancel the 2, you have the square root, so your velocity at the center is half gh, for example. This is just a derivation. Okay, the rest you read. At the end, you arrive at the same equation also. The energy doesn't, this slide, this three slides is just proof that energy do not change. This one you read through. It means energy do not change. You can prove from position 1 to position 2 to position 3, actually the magnitude of the energy is same. These three slides you read through. Okay. You read through. It means that if you always get this E equal to WH, this magnitude. Yeah, the rest you read. Okay. Okay, you still see if the question mentions subject only to conservation force, means you add the substitution, the summation of kinetic energy plus potential energy before equal to after. It means this one is, if you see the word system of particles, means there are many components. You have 2 spring, you have 3 spring, you have 2 mass, and so on in the system. And then you calculate individual object, the motion. All right. Okay, we look into this example and we have a break. Okay, so this is an example of you testing aircraft. Okay, a gangly structure means you hang an object on the air. Used to test the response of the aircraft during a crash. The plane is having a mass of 8 megagram. So just be careful. You will start seeing mega, ton, different unit from chapter 3 onwards. And it hoists back until degree equal to 60 degrees. So on the diagram, you pull back 60 degrees. And then the pullback cable is released when the plane is at rest. Meaning you cut the cable AC. Determine the speed of the plane just before it crashed into the ground at angle 15 degrees. So you change from 60 degree to 15 degree. Determine the speed of the plane just before it crashed to the ground 15 degree. Also, what is the maximum tension developed in the supporting cable during the motion? Basically, this one is your free body diagram. It's actually free body diagram. Ignore the size of the airplane and the effect of lift caused by the wing during the motion. So this one, you take out the lift effect. It's only on dynamic question. So even you're given the angle here, you just see it as XY component. And you've set a datum for your, datum is given. So basically, this question is fall under the conservation of energy, work and energy. So you need to be careful. The datum is on the top, meaning your energy, potential energy will be negative later because it's below datum. Okay. So we determine can you determine the speed of the plane at B? You can use, right? you can determine the speed of the plane at B, right? If you cut cable AC. What equation you use? What is constant? This is a free fall question. A is constant. The motor is not turned on. The aircraft is just free fall. It's like you're throwing something in the air. All right. So A is constant. V you know or not? V before you know or not? Zero, ma? So this is unknown is the velocity here. You know the displacement or not? Do you know the displacement? What is the displacement of position A to B? You see it as X and Y axis. What is the change of Y? A to B. Now you because the angle actually to confuse you actually. The trick of this question is given you the angle and it trick you again. You don't be tricked by the angle. You see it as X and Y and where the object move in X and Y. Okay, so this is the original position. This is the last position. And you see as or you can see it as from the datum lah. But basically, this is a change of S, right? And this is a change of S, right? So basically, you have two directions. One is horizontal, one is vertical. But you recall back the Newton motion equation, right? So you have your VA, you have your VB, right? And you have your vertical displacement and horizontal displacement. You know your acceleration is constant. So basically, and here it do not ask you about time. It don't ask you time, so don't go and ask for more trouble for yourself. If the question do not ask you time, don't go and use the equation with time. So there are three motion equation, two with time, one without time. So you can use what? V square equal to U or VO square plus 2A delta S lah. S1 minus S2 minus S1. Okay. This one will come out in your test later. Memorize. Okay. Okay. And you see as X and Y motion, right? You see in X and Y, or vertical, I call it vertical and horizontal lah, motion lah. You know, you can calculate the S, right? You can calculate the S, right? Do you know how to calculate the S? Uh, uh, okay, but the concept later I explain. So this one is X and Y. Okay. Okay, so you know how to draw free body diagram. And if you release the aircraft, what will be the motion? Will it move in a straight line? Or it move in the collinear motion? You tie a rope to the object and you swing it. You move in collinear. So it look like linear, but actually it's a collinear question. Collinear question, you need to call out collinear question solution. where there's a curve, then you need to call your AT-AN equation. AN equal to AN equal to V squared over rho. That one you need to recall lah. Okay, you draw free body diagram for the aircraft, and you have tension and normal because it's a collinear motion. It's a curved motion. So weight always go down. You draw the free body diagram based on the initial position and after position. So before is weight always go down. Then there's a cable there, right? The cable always in the center in this case, right? Of course, in the diagram, your cable is a triangular tension cable, but in this case, because we do not complicate the question, the angle between the cable is not given. So we just assume one tension cable to the center of mass there. Okay, then there's an angle given. It's angle given. In this case, we see as when the question asks you to focus on before it crashed. So we use 15-degree angle. Then we use conservation of energy to solve this question. So conservation of energy equal to energy before equal to energy after. So here basically is kinetic plus potential before equal to kinetic plus potential after. I put A and B is because of the location of A and B. What is the equation for kinetic? Half mv square. VA, V is potential. So potential is negative here because the datum is above the object, or the object is below the datum. So in general, you can write like this. Half mv square minus WH or mgh equal after, right? A and B, right? Then you substitute the value, you know. There's only one unknown is in the equation, which is VB. Right? Mass, you know. Just want to be careful. The mass is in megagram. You need to convert 8 megagram equal to 8,000 kilogram. V, okay, for A is 0 because you release from rest. So you can straight away cancel VA. VA squared. It becomes 0. All right. H is 20 cos 60. You can calculate H. H is here. H is here. H is here. Or here. And you have your angle here. It depends on how you read it. So this one is 60. You find your H here. 60, 20. So it's a cos. You are calculating the H here. Why you use H? Because you are dealing with potential energy, mgh. Sign is wrong. Sine 30, yes. You get the same magnitude. Okay, there's only one VB. VB here is square, so you have a square root answer. Square root answer means you have positive, negative root. So choose the one that give you positive value. So V equal to 13.52 meter per second. So this is the advantages of using potential energy. you don't need to find the motion. You don't need to find the velocity before, after. Just straight away use energy to solve. If the question do not ask you acceleration, you can use conservation of energy to solve. Okay. Okay, what is the speed before it hit the ground? Already fine. Then maximum tension. So you use free body diagram and kinetic diagram. So it's before, ask you before hit the ground. So we go back to this free body diagram, the force on the left and force on the right, and you look into normal and tension direction, like what you learned in your chapter 2. So I'll just show you lah. So you put in all the equation, just need to highlight that you call back the AN equal to V square over rho. In this case, rho is given, or the radius of the curve is given. If it's not given, then you need to use the differential equation. Okay. You substitute the value there. There's only one unknown, which is T is missing in the equation. The answer will be 149 kilonewton. Okay, the rest is substitution. Substitution. Any question so far? Okay, so yeah, we'll stop, have a break here. 10 minutes, we continue 9:20. 920.